Okay, we have to calculate the two one-sided limits of this function at x equal to 0. And the problem of this function is that it is a quotient of two functions, right? One of them is this integral, which for x equal to 0 is equal to 0, and the other one, the denominator, is x cubed, which is also 0 when x is equal to 0. So the limit of this function when x goes to 0 on either side is well, it's a kind of 0 divided by 0 indeterminacy. All right, so what we have to do is to, for instance, to apply L'Hopital. L'Hopital is always a good idea when you have an integral like this, because when you take the derivative of an integral, then you get rid of the integral. So let's apply L'Hopital. So we calculate the derivative of the numerator, okay, and this derivative using Leibniz rule is equal to the tangent of the square root of x squared times 2x. Okay, and in the denominator, what we have is 3 times 2 is 6, x squared, right? We can simplify this expression, and that is equal to the limit when x goes to 0 plus or minus. The square root of of x squared is the absolute value of x, right? So we have that, and 2x cancels with 2, with factor 2 and factor x down here, and you have down here 3x. All right, so let's calculate. Well, of course, this is 1/3 of the limit, and we can use the fact that the tangent of the absolute value of x is the absolute value of x plus O of the absolute value of x, right? O of x, actually. O of x, right? Okay, so when x goes to 0. So if we substitute this, then what we have here is the absolute value of x plus O of x over x. And here we have 1/3 of the limit when x goes to 0 plus or minus of the sine of the function x, right? Because the absolute value of x divided by x is just the sine of x. Okay, plus O1. So here are the two limits. When x goes to 0 on the right, this is plus 1/3. When x goes to 0 on the left, the sign is -1, so you have minus 1/3. So these are the two limits of this function f, right?